So combining expansion and compressions with shifts. So that's going to be a little bit more challenging, and especially with the x's. The y is not too bad because we can just read the expression, and the order in which we would do the expression is how we would do the transformation as well. But with the x's, it's going to be backwards. So when we start doing expansion and compression with shifts, it's really kind of hard. What do we do first? What do we do last? And we have to at the same time be thinking opposite operations. So that makes it a little bit challenging. So in this case here, really the issue is we can identify, well, that's probably going to be compressed by 3. That's a shift to the left, 3. But which happens first? And does it matter? Well, the answer is does matter. You can't, depending on whether you do the shift first or shift last, we're going to get different transformations. So we need to make sure that we get the order right. So we need to make sure we have a process to get the order correct. So here we have an absolute value function. Okay, so I'm just going to do my table over here, my absolute value table. I'll do it in black here. The only coordinate that I need to make sure I have is my 0. I'm going to go -2 and 2, 2 and 2. Really don't need much more than that because I know that what my absolute value looks like, and once I get my vertex and a coordinate, I pretty much have the graph like that. Okay, now if you want, you could put more coordinates to transform. I'm only going to transform 3 coordinates though. So there's my original function. This is my transformation horizontally. Well, I'm just going to make sure that if it's only a horizontal transformation, I know that my y coordinates don't change. Okay, so those are my 3 y coordinates. I'm just going to make sure I have that down first. So what happened to the x's? Okay, so my x's here, I know I have compression and shift. Okay, so it looks like this, 3. But what happens first? Well, this is where that process of solving comes in really handy, because this is my notation. This is what I see in my function notation. And I need to, if I want to get the order correct, all I have to do is undo this in the order that I would solve this. And it will undo things and rewrite the expression in the order that I need it to be in. So the first thing I would do to solve for this other end here is subtract 3. So I'm going to end up with 3n equals x minus 3. The second thing to solve for this x is divide by 3. So what ends up happening then is I now have the expression to calculate the new coordinates. And it tells the expression is in the correct order. I subtract or left 3 first, then compress by 3 last. Okay, so this is my do. This is what I'm going to do. Okay, this is the actual transformation here. So I take these coordinates. I'm going to take away 3, so I get -5 divided by 3. That coordinate becomes -5 over 3. This coordinate I'm going to take away 3 and divide by 3. I get -1. Take away 3, divide by 3, I get -1 over 3. And these now represent the x transformations. And because I had it I was able to rearrange it in the right order, I don't have to guess it backwards. I don't have to guess at what comes first. I know that I can shift first, then compress. Now, I'm just going to graph this and just make sure that I get the right graph. So I'm going to get -1 2/3, 2 up, -1 0. This is -1/3, 2 up. So there's my horizontally compressed graph. It's going to be narrow V. Okay, and it's been shifted to the left 1. Okay, so if I shift to the left 3, then compress, yeah, that makes sense. That vertex would end up back at -1. So this is a nice thing about this. The other thing about this, though, is that the algebra never lies. The algebra is algebra. And if you want, some people may have said, well, why don't I simplify this expression and say this? I can rearrange it to divide first and then minus 1 after. And those are algebraically the same. Okay, so they should theoretically, in fact, they're the same calculation, just written differently, but they'll give me the same transformation. So I can still do that, use this. So it doesn't matter how I rearrange it. This is algebraically true. This must be algebraically true. Now, although this is expressed as shift first and compress last, this one's actually compress first and shift 1 to the left. Well, that would do the same job. So there are different ways we can do this, but one way to keep track of things is this idea of solving or undoing.